So if it says that the interest is compounded continuously, that means that we're using the PERT formula, or in other words, the E is the base, 8% is the rate, and P is the original amount invested. So the principal of $1,000 is invested at 8% that's compounded continuously. That means each and every moment, at least in theory, each and every moment you're getting paid a tiny little bit of interest. And then find each of these. Now substitute a 10 into this function. And then find out how much that is. So 1,000 and an E to the point. Let's see, move the decimal place over by 1 by multiplying by 10, so 0.8. So this would be $2,225.54. So in other words, your $1,000 10 years later would be worth $22.25.54. Now take the derivative. So the derivative of the E function is going to be the E function. But then the chain rule says we need to take the derivative of this exponent and multiply. And then substitute in a 10. So that's actually the last answer except multiplied by an additional 0.08. So I could just take the last answer and multiply by a 0.08, and it's 178.04. Okay, and then take the second derivative, so that's going to be the derivative of the derivative, first of all with respect to t. So go back to the derivative here and take the derivative of that. So it's going to look the same, except we need this, the chain rule, again, so this is then going to be 0.08 squared. And then substitute in a 10, and we're about done. So the second derivative is going to be 1,000, and then e to the 0.08, and then multiplied by the 0.08 twice. Which then means take that last answer, which was only multiplied by 0.08 once, and multiply by 0.08 again. So we go from a little over $2,000 to 178 to 14. And now explain. So this one is just the original function, which says take $1,000, put it in the bank at this rate, you'll end up with $2,225.54 after 10 years. So in other words, it grew by about $1,200 per year. Of course, since it's exponential growth, at the beginning it grew by less than that. Towards the end, it's grown by more than just an average of $1,200. So what I'm trying to say is this, if you subtract the original $1,000, is a profit of $1,225, but it took 10 years to do it. That means that it was an average of $122. But since it's exponential, it doesn't grow at the same rate the whole time. Later on, it's growing faster and faster. Earlier, it's growing slower. So this is saying, well, the average over those 10 years was 122. If you just went across straight like that, it would be an average slope of 122. This is then saying, by the time you get over here, it's growing at a rate of 100, so the tangent line tells you how fast it's growing, $178 each year. And then what about the second derivative? Well, then that's the derivative of the derivative. So that's saying, okay, this is going up. How fast is it going up? So how fast is the velocity changing? It's also known as acceleration. It's accelerating at about $14 per year. We can sort of ballpark test that idea by saying, what if we went another year over here and went to 11? So take 1,000 and then e to the 0.08 times an 11 years. So I'm just substituting 11 in there, and then times 0.08, it's 192. And this was 178, so subtract the 178.04. So it changed by $14.83. Keep in mind what I'm doing over here is, like I did over here, the straight line is just an estimate. You actually have to have the derivative for the actual answer. So that's the actual acceleration. My estimate was that it was going to change by about $14.83. So that's how fast it's accelerating. This is how fast it's growing, and this is the amount.